So hello guys, welcome back. Today we will discuss some problems from integration B, but not from MIT, from some other university I have chosen. And what I was planning was I have brought in some FITG Ai2Ts questions today because I was exploring through the papers and I found the questions were really good. So I thought I should bring them up. So guys, this will be the first question, and I should also mention that today I have brought in two questions from 2022 Berkeley Integration B. If you have heard Berkeley's name, it's a very famous university. So this will be the first question guys for today. And let me tell you, both of these questions are really crazy, okay? This one also and the next question also. So you can try this out yourselves and I will wait for a few seconds. And if you want some hints, it's like you have to just observe the nature of the graphs. And this is something that we have already done 1,000 times in GE. Okay. So you can try it out, guys. I will wait for a few seconds and then start off. Okay, guys, I guess now it's time for me to solve this. So basically, as you can see, this is integral of 0 to 2 pi minimum of sin x comma cos x whole divided by maximum of e power sin x comma e power cos x. So first, let's look into the numerator part. So for that, basically what I will do is I will try to draw out sin x and cos x graphs together. So if this is the somewhat the coordinate axis, then the sine curve goes something like this, and your cosine curve will go something like this. That's it. And now I guess if you actually observe, the trick where this question actually becomes difficult is that you can't solve this directly. Okay, I will show you how why. Because if you see this particular part, you know this point is here pi by 4, right? Sin x and cos x, first they intersect at pi by 4, and the second point where they will intersect this point, this is your 5 pi by 4. And I guess we will not need any more multiples. Rather, if I want to write this, then I will write sin x equal to cosine x, or x is equals to pi by 4 comma 5 pi by 4. Like, we are not taking values beyond 2 pi because that's the upper limit. Okay, so now if you see carefully, I will use a different color to depict this. Basically, if you see minimum of sin x comma cosine x, so up till 0, from 0 to pi by 4, you will see that minimum is actually sin x, but after pi by 4, minimum becomes cosine x. Again after 5 pi by 4, like it keeps alternating, okay? Like if we draw a number line and mark 0 pi by 4, then 5 pi by 4, and after that 2 pi, you will notice actually we have three intervals across which actually we have to evaluate this integral, okay? And if I want to write out like minimum of sin x comma cosine x, in which interval which one will be, then for the first interval 0 to pi by 4, as you can notice, minimum is actually sin x. So here goes sin x. After that it will alternate, it will become cosine x, again it will become sin x, and this goes on, okay? Sine cos sine cos sine cos, it will go like that. So that's the numerator, and we also have to like evaluate the denominator where it is given e power sin x comma e power cosine x. Okay, now if you observe something carefully, e power sin x, if we actually equate it to be equal to e power cosine x, then actually sin x equal to cosine x, so the solutions are same, which means that the curves of these two will actually intersect at the same points. And also nonetheless, because e power sin x and e power cosine x, actually the graphs will not be like this, it will be somewhat different, but the nature of maximum and minimum will actually be all like exactly similar that to what is happening here. I hope you guys understood. So if you see from 0 to pi by 4, first our maximum was your cosine x, right? So if we want to determine for e power sin x and e power cosine x, then maximum first will be e power cosine x. I will quickly change the page and write it down here. So if you see this carefully, first our maximum was your cosine x, so first will be e power cosine x, and then again it keeps alternating. After that we will have e power sin x, and again we will have e power cosine x. This is the breakdown of the entire integral that we have to solve, and we have to evaluate across three intervals with separate pairs of limits. So I guess now it's time to write this down. So if you want to write this, this will actually become your integral of 0 to first is pi by 4, and this is sine x whole divided by e power cosine x dx plus of integral of pi by 4, and this is up till 5 pi by 4. Next we will have cosine x by e power of sine x, this is cosine dx plus of integral of 5 pi by 4 till 2 pi. This will be your sine x by e power cosine x dx once again. So that's it. I guess now we have the integrals ready with us. Solving this is not a pretty difficult task. For example, if I want to show this one, say we'll take your sin x to be as u, or I will not take u because we have 3. Okay, I will take it as a. If we take sin x as a, then your cosine x dx, just a minute guys, I guess not sin x, I should take cosine x as a, then your minus sin x dx will come out to be as dA. Similarly, here you will actually take the numerators. You take, sorry, not the numerators, the term or the power which is present in e. So here cosine x, we will take sin x as say b, and here we again take your cosine x as say c. And I am not going into that evaluation. This is pretty simple. Okay. So I am changing the page to further write this down. So if you observe carefully, this thing is actually your integral of, because we took cosine x as a, right? So 1 pi by 4, so 1 by root 2, and a minus is obviously there because of this. And this is your dA by a. I'm not sorry, this is your not dA by a, it's e power a. dA by e power a. Plus of integral, this thing will become 1 by root 2 to minus 1 by root 2 dB by e power b. And this is again, you will have a minus integral minus 1 by root 2 to 1 dc by e power c. So that's the final breakdown, and now this is pretty simple to solve. I am not going into writing this I hope you can understand, right? E power minus a dA integrated, so it will be your, this minus will get minus minus plus, so e power minus a from limits 1 to 1 by root 2. After that you will have minus of e power minus b from limits 1 by root 2 to minus 1 by root 2. After that you will have, this will become plus, so e power minus c from minus 1 by root 2 to 1. So I am directly writing that. This can be done mentally, I guess. Easy stuff. So e power minus 1 by root 2, because there was e power minus a. After that we will have e power minus 1 and e power minus 1 by root 2 minus of e power 1 by root 2 plus of e power minus 1, and I guess here we will have your e power 1 by root 2. So I guess some cancellation is occurring. This and this will get cancelled. So finally you have 2 e power minus 1 by root 2 minus 2 e power 1 by root 2. And this can be like your final answer, but I am taking this a step ahead. You will understand why I am doing that. I can actually write this as your e power of 1 by root 2 minus of e power minus 1 by root 2 whole divided by 2. I took the minus outside. There was a 2 already that I have taken common out, and I divided with the 2 again, so minus 4 in total. Okay. Now you can ask me why have I written this. So I would like to go into a little bit introduction of your physics, where because I have done this myself, so I know. If you observe your 2016 rotating disk frame question from rotation, a very famous question, you all know that. It was, I guess, the toughest in JEE Advanced History in physics. So if you see that question, if you have solved that question, or my teachers taught me how to do that, there are many methods developed nowadays, but there is actually a method where we use sine and cosine hyperbolic. If you guys don't know what it is, I will write that down. And please note, this is actually not in your syllabus. Sine and cosine hyperbolic is not supposed to be in JEE syllabus, but because they had given this in 2016 physics, so I guess you should know that. Okay. So if we write down, then sine h of x, this is called sine hyperbolic. This is your e power x minus of e power minus x by 2. You don't need to go into the proofs and all. That is not required. If you want, you can remember this. And if you don't want to remember, there is also not a problem. You can treat this as the final answer. And if you want to write cosine hyperbolic, It is e power x plus e power minus x whole divided by 2. So I guess you can now identify why I have written this like this form. So minus 4, and now I can write this as sine the hyperbolic, and in place of x we will have 1 by root 2. So this will be your final answer. Actually, in the Berkeley integration B official solutions, they had given this as the answer. So I wrote that. But anyways, if this comes in your JEE Advanced, either they will provide you with this information or they will give this as the answer. Okay. If you don't want to know this, then no problems. But because this has some application in your physics, I have done myself. Like in my preparation, I had done this question using sine hyperbolic. So I guess you should maybe know it. Okay. So that's it for this sum, guys. I hope this was interesting. So now I will go on to the next question. So here's the next question, guys, and you can give this question as many stars as you want. This is a great question. And before you guys want to try this out, some important words that I would like to say. First thing is please, this is not x square, this is square root, cube root, fourth root, and so on. This is ln x power 1, ln x square, ln x cube, and here we will have obviously ln x power 0. That is not written. It's obvious. And one more thing that I would like to say before you start solving this, I will solve this actually using two separate methods. Okay, I have developed two methods, and both the methods are actually visible in the first step itself. So if you want to solve this question, I would recommend please try to find out the two methods. Okay, because if you have done enough of calculus, you will know that like these two methods will be pretty obvious to find out. So if you can, please develop two methods. Otherwise, if you develop one method, then you can come and check on the solution. And if you have developed two methods also, like after seeing my solution, if you have some other way of doing this, you can also write me down in the comment section. Okay, because integration B questions are like, they are very good, such good level questions, then multiple methods keep evolving to solve a particular question. Anyways, guys, now it's time. You can solve this, try it out, and I will wait for a few seconds. Okay, guys, I guess now it's time for me to solve. So let's write this down, integral of 0 to 2, and let's like, this is your x power 1, this thing is your x power ln x by 2. Okay, if you write, after that you will have x power ln x square by 3, also another 2. So ln x square whole divided by 3 into 2, which is 3 factorial. Okay, so I guess next if you see x power ln x whole cube by 4 into 3 into 2, and like that it will go on. So you can notice a pattern. Basically, if the powers of x are multiplied, you know that we can add all the powers into 1x. So this thing is your 1 plus of ln x by 2 plus of ln x by 3 into 2, which is actually your 3 factorial. Okay. After this, okay, this is your ln square x. After this, if we write, this will be your ln cube x by 4 factorial, and this will go on till infinity dx. So that's the breakout. You can also write this as 2 factorial if you want, no issues. So you can notice there is some sort of an expansion, which we can write as integral 0 to 2 x power of, and I will try to write this in sigma form. Okay, so sigma n equals to 1 to infinity, and this thing is your, I guess, x power 1, and the denominator is actually 1 greater than the power in the numerator. So we will write this as whole divided by n factorial, and here we will write ln x whole power n minus 1. So now a pretty obvious question is how to solve after this particular step. Okay, so actually here you have to use some knowledge of expansion, which I guess you might have learned in limits, which is your sigma n equals to 0 to infinity x power of n by n factorial. This is actually equals to e power x. Okay, this is nothing outside your syllabus, well inside. So we know this standard expression, And because if you see, the reason I chose this one is because this and the thing we have here are pretty much similar. Only sigma n equals to 1 and n equals to 0. And also there is an n minus 1, so we don't need this minus 1. So what I will do is, I will write this as integral 0 to 2 x power. I will pull out this ln x power minus 1. So 1 by ln x. And here we will have a sigma n equals to 1 to infinity ln x whole power n by n factorial and a dx. So now it's, I guess, pretty much similar. And now we will do some manipulation on this particular thing. So I will change the page. Don't have space. So let's apply some brains, guys. What I will do is, I will write this as sigma n equals to 1 to infinity x power n by n factorial. So basically the term which we excluded is n equals to 0. It is x power 0 by 0 factorial, which is 1. And this is equals to your e power x. So what I can write is sigma n equals to 1 to infinity x power n by n factorial is actually equals to e power x minus 1. So now what I can do is, I can substitute in place of x, we can substitute ln x. So we will have our required expression n equals to 1 to infinity ln x power n by n factorial. This thing actually becomes your e power ln x minus 1, which is basically x minus 1. So this is our resultant expression that we will actually need to solve this. Okay. So now I guess things are pretty clear. So let's substitute this quickly into this integral. So we will have your integral 0 to 2. And this thing becomes x power 1 by ln x. And also we will have this thing as x minus 1 dx. And now again we will apply a very simple property of logarithms, which you all have learnt. We can write x as e power ln x. So here we will have x minus 1 by ln x dx. Reason being because there is easy cancellation of ln x and ln x. So now it is nothing but integral 0 to 2 e power x minus 1 dx. So you can see that huge thing was actually reduced to this. Okay, this question is crazy. Like, I have no words to describe what sort of level this question has. Anyways, so integral 0 to 2 e power x minus 1 dx. This is pretty simple. E power x minus 1 itself from 0 to 2. So if we try to like evaluate this thing, this actually becomes your e minus 1 by e. E power 2 minus 1, e power 1, and e power 0 minus 1. So e minus 1 by e. This will actually be your final answer. So this is the final answer for this question, guys. And now I promised that I would use two methods. So this was the first process to do this, and I will bring the question once again for your reference and solve this using a second method. So let's proceed towards that. So let's solve this using our second method. So second method is actually I am trying to do a substitution. Okay. What I will basically do is I am taking ln x as some y, because I can see ln x is everywhere. Or basically we will put x as e power y. So if you now differentiate this particular thing, dx will be equals to e power y dy. So if we want to rewrite this expression, we can write integral 0 to 2. This thing is your x, so e power y. Now here we will have x power ln x. Okay, so e power y whole power y. Basically this becomes square root under e power y square. After this we will have your e power, I guess, y power, e power y cube, I guess, and that is cube rooted. So cube root of e power y cube. Again this goes, and after this we will have a fourth root of e power y power 4, and this would go on, okay, till infinity. And one thing which you should not forget is that we don't have only dx now, we have dx in place, it will have e power y dy. Please take a note of this. If you miss this e power y, everything will go wrong. So now I can write this thing as like the earlier step, we can sum up all the powers. So basically this will become e power of, this is your e power y plus of y square by 2 plus of y cube by 3 factorial once again. And this is your 2 factorial, and this thing goes on till infinity. So almost similar type of case which we had. And now I would suggest one thing, please don't include this e power y in the powers, okay? Please keep it separate. Actually, there's actually a reason why I am doing this, because if you include this in the powers, this will actually cost you the last step. Okay, this e power y is very important for the last step, so please keep it. Okay guys, I am changing the page. I have no space left here. Also, I forgot one more thing. Actually, I forgot to change the limits. I should have changed in this step. Anyways, I'm writing it here. Actually, this will become minus infinity and this is becoming ln 2. Okay, I forgot to change the limits. Please do that. So if we now see, this is actually some sort of similar to what we actually found. Sigma k equals to 0 to infinity y power k by k factorial. This is equals to, as we all know, e power x. So now we don't have k equals to 0 term, so generally there will be a 1 here, like the earlier step. I am not writing that. Sigma k equals to 1 to infinity y power k by k factorial, and this is not e power x, I'm sorry, it's e power y. So e power y minus 1. We have e power y minus 1 here. So I guess now it's time to substitute. So this thing becomes your minus infinity to ln 2. And this thing is your e power of e power y minus 1, e power y dy. Actually, this is where this e power y is very important. Basically, if we take e power y minus 1 to be t, and differentiate this, e power y minus 1, and again we will have e power y dy. This thing actually becomes equals to dt. So you will have integral dt, which is t, and in place of t, if we substitute this thing, so we will have your e power of e power y minus 1 from your minus infinity to ln 2. So basically now if we put on the limits, this actually becomes e power ln 2, so e power 1 I guess first, and minus infinity, so e power minus 1. So as you can see, our first answer and the second answer are exactly matching. So this is it for the second method, guys. So as you know, I guess you can understand, both the methods are pretty evident if you look carefully to the question. Okay. So this was a great question, guys. I hope you like this question. So that's it for the Berkeley integration B, and I should also write down, this is a 2022 Berkeley integration B question, like both of these. Okay. So I guess this question was done. So now I will move on to some FITGI Ai2Ts questions, good questions that I have brought today. So this will be the first question, guys, for today from the FITGI Ai2Ts. You can try this out if you want. I will wait for a few seconds. This one is a good question. Okay. So please try it out. Okay guys, I guess now it's time for me to solve. So basically we have integral of secant square x dx divided by tan power 101x plus tan x. So something that might have instantly knocked your mind is that there will be some sort of substitution for tan x, because secant square x is perfectly visible. So if we write down the question, this is your integral secant square x dx whole divided by tan power 101x plus of tan x. So if we want to evaluate this some sort of, what we can do is we can take out tan power 101x from the denominator. This might seem a little absurd, but you will understand how. And I can write this as 1 plus, and now tan power 101x has been pulled out. So tan power minus 100x will be remaining here. And we have our secant square x dx obviously. And now what I will do is I will take 1 plus tan power minus 100x, this part, to be equals to, say, t. So if we differentiate this, this becomes minus 100, tan power of minus 100 minus 1, so minus 101x, and then secant square x dx to be equal to dt. So as you can see, if I take a separate color and try to depict this, so this part was our t, and actually this complete thing here this goes out with dt by minus 100. So that's why I took this particular part as t. Okay. So now now this has become pretty simple. This is your integral, I guess, minus dt by 100t. So if you see, this thing actually becomes minus 1 by 100 ln t plus c. And now if we introduce the value of t, this becomes, just a minute guys. Yeah, so if we substitute t, so ln of 1 plus 1 by 10 power 100 x plus c. And now if you actually observe, we don't need to calculate the constant. Okay, this is sort of bluff, because limit extends to pi by 2, g of x is what you have to find. This is your g of x. Okay, so I don't know why they have given this, maybe to sort of bluff the students and waste their time. And if you still want to calculate constant also, like they could have given this completely as g of x and said that we have to find out. That would have been a better option, because if you see, actually if you put g of pi by 4 as minus ln 2 by 100, you will see c is actually coming out to be 0. So either way it's the same thing. So this is our g of x, and now we have to find out limit extends to pi by 2 g of x. So let's do that. So we have to find out limit x tending to pi by 2 minus 1 by 100 and ln of 1 plus 1 by 10 power 100 x. So there is absolutely nothing difficult. If you substitute pi by 2, so 10 power 100 pi by 2, this actually becomes your infinity. So 1 by infinity is 0, so ln 1 is 0. So 0 is your answer, and if you want to know the option, it's option number A. This was a good question. Like, actually, FITGI Ai2Ts has a pretty number of good questions, not in the recent papers, but if you go back to 2016-17, those papers have really great questions, okay? Out of the box, like something we have not done before. So I will try to bring them out also. I am testing this, whether this thing is actually looking nice or not. Anyways, so we will move on to the next question for this series. So here's the next question, guys. This question is a bit tricky, but if you can identify the first step itself, then the question becomes very simple, okay? So you can try this out, guys. I will wait for a few seconds. Okay, guys, I am now solving this. So basically, as I said, one step and this question is finished. So if you read the question, a and b be two distinct roots of the equation, this, and the equation which has ab as its root is equal to. Okay. So as you can observe, this is a cubic equation, and also a and b are distinct roots, which means that there will be obviously a third root. Okay. So I am taking the third root to be, say, some c. Let c be our third root. So if you observe, actually, like I said, one step and this question is over. If you actually write down the product of roots, this will be ABC, which is equals to, I guess, 1. So C is equals to 1 by AB. Okay, and now just this step and the question is absolutely finished. So if we now take our main equation, which is x cube plus 3x square minus 1 equal to 0, you will observe that we can put c, because it's a root obviously, right? So c cube plus 3c square minus 1 is equal to 0. And now we can substitute in place of c 1 by ab. So 1 by ab whole cube plus of 3 times of 1 by ab whole square minus 1, this is equal to 0. So if we evaluate this, we will actually get minus of ab whole cube plus of 3ab plus 1 is equal to 0. So if we actually observe, we can substitute x in place of this. So minus, like, this is the equation which has ab as its root, right? So we can substitute x. Minus of x cube plus 3x plus 1 equals to 0. So multiplying both sides with a minus, x cube minus 3x minus 1 is equal to 0. So I guess this is our option number A. So this was it. This is not a very difficult question, but yeah, some trick in this part which you need to identify. So anyways, this was the second question, guys. Now I will move on to the third question. So here's the next question, guys, and this question was a very beautiful question. You would need god level practice of integration to solve this. Okay. If you have solved too many books, so too many sums, then only you will be able to see like what to do. So you can try this question out, guys. I will give you a small hint. It's everywhere, like nothing else to be applied, only by parts, application of by parts. But still, you have to, like, it will not end with a single by parts. Okay, after that also a lot of thing has to be done. So you can try this out. I will wait for a few seconds. This is a good question. Okay, so I guess now it's time to solve. So if we write this down, in, it's given as, so this is integral of 0 to 3 pi by 2, and ln of mod sin x. Let's not mess up with the mod, let it be. And then we have cosine of 2nx dx. So if we try to apply by parts to this, I guess we can take this thing as u and this thing as v. Okay, this one is actually pretty like easier to integrate. So let's quickly do that. So first part will be ln mod sin x, and cosine 2nx on integration will give sine 2nx whole divided by n. So ln mod sin x, and we will have, I guess, sine 2nx whole divided by 2n, and this thing is 0 to 3 pi by 2. So if you I'm evaluating this later on. Let's first write down the second integral, which actually comes out to be integral of 0 to 3 pi by 2, and I guess we will have like ln mod sin x. So on differentiating this, it will be sin x in the denominator, and after that cosine x in the numerator. And because 0 to 3 pi by 2, so I guess mod will open with a plus, so this becomes cot x, like cosine by sine, so cot x. And then we will have sine 2nx whole divided by 2n. You can put this in a bracket if you want, dx. And now let's quickly evaluate this particular thing. If we actually put the limits 0 to 3 pi by 2, and sine 0 is obviously 0, here also sine 0 0, and after that 3 pi by 2, so sine 3 pi by 2 is actually 1, and like ln 1, so it is 0. We don't need to evaluate this. So I guess this thing actually collectively comes out to be 0. So guys, before proceeding further, I would like to show you something in this particular part which most of you will overlook. Okay, this is actually something very important, and although JEE Advanced has not yet introduced this concept somewhere, but in the later years this can be used. Okay, like a few seconds ago I told you that ln mod of sine, when we put the limits, ln mod sine 3 pi by 2, so that is ln 1, which is 0, and this part doesn't matter. But when we are actually putting 0 as the limit, sine 0 is 0, but you know that ln 0 is not defined. It is not defined, right? But actually if you put 0 in this particular thing, you will get ln 0 if you put 0 here, which is where actually I should open this up and write it separately. Okay, so before proceeding, I would show this out to you, and these are very small minute things, but please keep this in mind, because JEE Advance will, like, this is assured that in the future JEE Advance will give you a question where they will trick you in this particular part. And anyways, if you are learning limits, you should know this fundamental. Okay, so first if we see, it's upper limit minus lower limit, so upper limit is like naturally coming to be 0 with no problems, but because ln 0 is coming in the second limit when we put the lower limit, so I am writing this as limit x tending to 0, and obviously 0 plus, because 0 to 3 pi by 2, right, not below that, so 0 plus ln mod sin x, and after this we will have sine 2nx whole divided by 2n. We are evaluating this part later. Okay, let this be here. minus integral of 0 to 3 pi by 2, and whatever stuff is there, let it be. First I will evaluate this part. So I am changing the page, guys. I have no space here. So if we want to evaluate this particular limit, like if you see x is tending to 0 plus, so sine limit is tending to 0, which means we can replace sine 2nx with simply 2nx. Okay, I did this in the first step itself. So 2n and 2n get cancelled, and yet again if we write this as limit x tends to 0 plus, again you will see that sine x, here also sine x, the limit is, the argument of sine is going to 0. So we can also replace this sine x with x, which means there will be 1x here and ln mod x. This is the limit that we have to evaluate. So what I will do is, now I will make a change of variable. I will write x as 1 by t, so that when x is tending to 0 plus, our t tends to infinity. So if we want to write this, this becomes minus limit t tends to infinity, and this thing becomes your ln t, I'm sorry, I guess not ln t, minus ln t whole divided by t. Basically it's 1 by t ln 1 by t, so I wrote it as minus ln t whole divided by t. So if you know that ln t will actually be much less than t when t tends to infinity. Okay, you can draw the graph also if you have any doubts. This is the curve of ln x, and this is the curve of y equals to x. So as you see, this thing is actually going towards this side, and this thing is increasing much rapidly. Okay, so if t is tending to infinity, ln t will be obviously much less than t. That means denominator is much larger than the numerator. So now this thing actually comes out to 0. Okay. You would ask me, why did I elaborate this so much when we had ln 0 but the other term was coming out to 0? So 0 multiplied with anything is 0. That is actually not mathematically correct. If you have ln 0 multiplied by some 0, and this is a form which actually doesn't exist. Ln 0 is non-existent. Okay, it's non-existent, you can observe from the graph. So it's not mathematically correct. In the exam hall, if you want, like, you can remember this part, this generally comes out to be 0, but please be careful, because JEE Advanced can trick you sometime later on in this particular part. Okay, I hope they will do. So anyways guys, this was 0, and now we can go on to solving the integral further. I will change the page. So finally our integral becomes in equals to 0 minus of, I guess this was integral of 0 to 2 pi, so sorry, not 2 pi, 3 pi by 2, and this thing is cot x sine of 2nx whole divided by your 2n dx. So that's it. And now you might have an obvious question how to proceed from this particular part. So what I am doing is, I am writing in as 0 minus of 1 by 2n times jn. Jn is another integral that I am considering. Okay, you can't solve this directly, we have to take this to be another integral and solve it out. Now question is how to. Okay, so for that, if you actually observe our question carefully, it had some I3. Okay, there was some constant here, I guess, I3 minus some constant times I2. Now if there is a subtraction here, I can go for a jn minus 1 as well, because if it's present here and in is minus 1 by 2n times jn, also there is no constant, just a constant multiplied but no additional constant available, which means that some sort of, if in minus I constant times in minus of constant times in minus 1 is present, we can go for the same here. So let's apply that and see if we are successful. So if we write jn minus 1, this actually comes out to be integral of 0 to 3 pi by 2. And now what we can do is, I can write cot x as cosine x, and this thing is whole divided by your sine x, and above we will write like sine of, I can put a bracket, sine of 2nx minus of sine of 2n minus 1x. There is shortage of space here, and dx also. Okay, dx is written above, there is shortage of space, so I wrote like this. So now we can write this as integral 0 to 3 pi by 2, and this is your Very simple trigonometric formula, sine C minus sine D. So if we evaluate that, this actually comes out to be cosine X. And I guess sine C minus sine D is 2 cos C minus C plus D by 2 sine C minus D by 2. So I guess this thing will come out to be cosine 2n minus 1x, I guess. And if we take the second term, I guess it's sine x. Okay. And here also we have sine x in the denominator dx. And I hope the 2 gets cancelled out. So now you can see there is a cancellation occurring, sine x and sine x. So that's the cancellation. And now we finally have integral 0 to 3 pi by 2 cos x cos 2n minus 1x dx. Okay. So if you actually evaluate this particular thing, this will come out to be, I'm writing it. You can multiply a half and 2 here. So half integral 0 to 3 pi by 2. And this is 2 cos c cos d. So cos c plus d by 2. I guess it's your cos c plus d by 2. So 2n minus 1 cos nx. And this is your cos c minus d by 2. So c minus of 2n plus 1, I guess that's 2 minus 2n. So 1 minus n times x dx. Now why this is not very important for us? Because, okay, there is a plus also here. This is not very important for us. Why? Because if you have watched my previous videos also, when there is some sort of a form in this thing and it's integral 0 to 3 pi by 2 or some multiple of pi by 2, generally this thing comes out to be 0. Okay. You can, if you want, you can evaluate this, but this is something like, these are not, let me tell you, these are not standard results. The much you practice, these things will keep developing inside you. Like, if you have done 100 sums on an integration like this, you will know that this thing will obviously come out to be 0. And if you want, like you are getting confused, you can evaluate this thing, this part, but it will come out to be 0. That's assured. Okay. So from here, if we notice, this thing actually gives us like jn minus 1, this thing is 0, which means jn is equals to jn minus 1. Or what we can actually write is jn will be equals to jn minus 1, again will be equal to jn minus 2, and this thing goes all till equal to j2 equal to j1. That's it. And so I guess we have the smallest in the lot, j1, which is the easiest to find also. So let's find out j1. If we find out j1, we will automatically get jn. So I will change the page. So if we try to find out j1, this thing is your integral of 0 to 3 pi by 2, and we will have sine 2x. This thing is your cosine x whole divided by sine x dx. And now you can break this particular thing as 2 sine x cosine x. So your sine and sine get cancelled. So you have integral of 0 to 3 pi by 2 cosine squared x dx, which you can again write as integral of 0 to 3 pi by 2 1 plus cosine 2x dx. So if you evaluate this limit, I guess this will come out to be 3 pi by 2 itself. Like, this is your x plus half sine 2x from 0 to 3 pi by 2. I guess this thing will come out to be 3 pi by 2. So if we go back to our old form, which is your in, it was 0 minus, so I'm directly writing minus 1 by 2n times jn, and jn is equal to this. So basically your in is nothing but minus 3 pi by 4n. And now things are perfectly ready for us. We can find out the values given. So I guess we have to find out I2 and I3, or I guess there was something like 12 I3 minus 16 I2. So let's first put I3, which is your minus 3 pi by 12. So 12 by 3 is minus 3 pi. This is 12. And if you also observe, I guess if we put 2, then we will have 8I2 equals to minus 3 pi. So multiplying again with 2, 16I2 is minus 6 pi. Okay. So if we subtract these two, then it actually comes out to be 3 pi. And we were asked the value of this particular constant, which means n is equals to 3. So this is the final answer for this question. This was a very good question, like perfectly fundamental based, and in very, like I showed you that limits part where ln 0 was coming. That is something that JEE Advanced will definitely trick you somewhere in the later years. Okay, either they will give something like they will directly give this form and then ask you about why, or maybe they will include this, like here in this integral it was included, they will include that in some integral and then trick you. But anyways, you should remember this. Okay, if you are learning limits, you should be very careful of these things. Anyways guys, I will now proceed to the next question. So here's the next question, and after a difficult question, let's go on to a little bit easy question. So you can try this out if you want. I will wait for a few seconds and then solve. Okay guys, now let's solve this up. So basically you can see we have to find out in which interval fx is decreasing. So for that, obviously we have to find out f dash x, which is your e power x minus 1 times x minus 1 times sine x minus cosine x times sine x, and that's it. So from here we have to find out the various critical points. So from here I guess only one critical point, x equal to 0. From here x equals to is 1. And from here I guess we will have x equals to pi by 4 and also 5 pi by 4. And from here we will have x equals to 0, pi as well as 2 pi. Okay. And also in the, like we will draw a number line. So in the number line it's our duty to include minus pi by 2 as well, because it's given in the interval. So let's draw a long number line because a lot of critical points are there. Let's start it from the left hand side. So minus pi by 2 comes first. After that 0. After that pi by 4. Then 1, pi, 5 pi by 4. And finally we will have 2 pi. So now the wavy will start from above. So I'm not drawing the wavy like that. Or if you want, you can also draw. Okay. If you want, you can draw. It will go something like this. But you have to be okay. This will be like this, and please be a little cautious because minus pi by 2 isn't a solution for this, so it will go like this. Okay, please be cautious in this part, or rather I should not draw it like that because it's a critical point. So let's do it like this. I will give a circle here and this will go. So this part is actually minus, but I guess we will not include this in our interval. But just a minute guys, I actually did a mistake. This was not correct. The part we did here was actually correct. This will be, I'm sorry I messed this up. This was not correct. Actually the graph will go like this because minus pi by 2 it will never come. Okay, because minus pi by 2 is in the root. So if we go on putting the different signs across the intervals, then I guess, just a minute guys, I guess I've done something wrong. Wait. Okay guys, I just messed that up. I was getting confused, so I drew this fresh. So let's start putting the signs. This will be plus, this will be minus, and after that this will be plus, this will be minus, this will be plus, again this will be minus. This is more fresh, okay, and easier to understand as well. And so there will be an obvious question that if you observe carefully, there are two options A and C which are becoming our probable answers, but which one to choose? So don't choose A because minus pi by 2 to 0, this particular interval is actually, it will not fit in. Reason being because minus pi by 2, first of all, it is not a root of this equation. That is enough proof. So I guess minus pi by 2 isn't a root. That's why I will not include this. So your option C will be correct in my regard, which is pi by 4 to 1 union with pi to 5 pi by 4. And if you want to find out the increasing interval, you can do that. So it's a 0 to pi by 4. This is your decreasing interval, and increasing interval will be 0 to pi by 4 union with 1 to pi union with 5 pi by 4 to 2 pi. which is I guess given in our option number B also. So if they had asked you to find out increasing interval, then not option number B, I'm sorry, option number D. This will be your increasing interval, this will be your decreasing interval. So anyways, our correct option for this question is option number C. So that's it for this question, guys. Now I will move on to a better question. So you can try this question out if you want. This is a good question on like lots of telescoping series involved. You can try this if you want. I will wait for a few seconds and then solve it. Okay guys, I guess now it's time for me to solve. So basically let's first write down our target expression, which is sigma r equals to 0 to 10 3 power r factorial times 3r square plus 5r plus 1 whole divided by r square plus 3r plus 2. So the first thing after writing this part, the first thing that should trigger your mind is that we can factorize our denominator as r plus 1 into r plus 2. And because we have to like, it's pretty obvious, we have to try to form a series. So we will try to write this particular quadratic in the numerator in terms of r plus 1 and r plus 2. So what I will do is I will write sigma r equals to 0 to 10 3 power r into r factorial. And because 3r square is there, I will write this as 3 power r plus 1 whole square. Okay. And after that, this is 3r square plus 6r plus 1. So, okay. Yeah, it's coming. We can just subtract the r plus 2. And now our expansion is absolutely ready. So we can split this up into two different fractions as sigma r equals to 0 to 10. The first one will be, I guess, your 3 power r and a plus 1 also because there is a 3 already. 3 power r plus 1 into r plus 1. And I guess you can give a factorial symbol here. Whole divided by r plus 2. Why? Because 1 r plus 1 is getting cancelled and r factorial into r plus 1 is actually r plus 1 factorial. And that is minus of 3 power r factorial whole divided by r plus 1. So that's the final expression and I will quickly change the page because I have no space here. So if we observe carefully, this particular thing actually it's a telescoping series. So if you start putting r equals to 0, for r equals to 0 in the first pair, actually the second term will be completely 0. And after that you will observe as the terms get cancelled, this term actually was supposed to remain, but this was completely 0, so it won't remain. And when you observe carefully, from the first pair, the first term will cancel. Okay, so I guess, or wait, I guess I'm wrong. Not the first term. From the first pair, the second term is actually equal to 0. So from the last pair, I guess 3 power, this term will remain. So 3 power 11 into 11 factorial whole divided by minus 12 whole divided by 12. This will be, I guess, your answer. Yeah. And guys, I guess this thing, okay, let me check. This is not actually 0. 3 power 0 into 0 factorial is 1 divided by 1. Okay, it's not 0, it's 1. I did a blunder. So in the first pair, if minus 1 is remaining, that is the second term is remaining. So in the last pair, the first term will remain. So 3 power 11 into 11 factorial divided by 12. And after that we evaluate, then this thing comes. Like you should not go into writing all the terms, okay? This is something, if you don't know how to do this, then I will quickly tell you. Just observe the telescoping series, observe the first pair and the second pair. If in the first, or you can just observe the first pair if you want. If in the first pair, the first term gets cancelled, the second term remains, then in the last pair, the first term will remain and the second term will get cancelled. Rest of everything in the middle will obviously get cancelled. That's how a telescoping series works. So this can save a lot of your time. Okay. So now I guess we are ready and we have to find out this and this given as m and n. So m equals to n equals to 11. And we were asked mod of m minus n plus k. Okay, we also have a second expression to be evaluated. So let's evaluate that first. This was, I guess, sigma r equals to 0 to 100. And for the time being, I'm writing that big thing as tr. Okay. So tr is basically nothing but your r square minus 3r plus 1 divided by r plus 2 factorial. So if we actually want to split this particular thing, what we can do is, there is an r plus 2 factorial in the denominator, right? I guess we can write this as r plus 1 by r plus 2 factorial. Not r plus 2, I'm sorry. It will be r plus 1 minus of r plus 3 by r plus 2 factorial. Basically, how I did this was, you can write r plus 2 factorial here as r plus 2 into r plus 1 factorial, right? And after that, you can express this in terms of r plus 1 and r plus 3 and then split it up. This is pretty easy. I did it mentally right now, okay? I'm solving this live. I didn't work this out before. So I guess now we can put sigma r equals to 0 to 100, your tr, and I guess again this is a telescoping series. So checking, first pair has your 0, 1 by 1, so 1 minus of 0 plus 3 by 2 factorial. After that, if we do plus and put n r equals to 1, so 2 by 1 plus 1, 2 factorial, minus of 1 will be, I guess, 3 plus 1, 4 by 3 factorial. So 4 into 3 factorial and again 3 by 2. Okay. We'll write one more pair. For r equals to 2, this thing is 3 with by 3 factorial minus of 5 by 4 factorial. So I guess 5 by 4 factorial, 4 by 3 factorial. I guess 3 by 2 factorial will actually remain. And I guess the last term is remaining, which is your minus of 103 by 102 factorial. This will actually remain, I guess. I hope I'm correct because the intermediate terms are getting cancelled, I guess. Minus 4 by 6, which is 2 by 3, right? Yeah, I guess the intermediate terms are getting cancelled. Okay, guys, I actually did a big blunder. That's why I was wondering why this was not matching. This is not r equals to 0, this is 1. So basically, the term in which we put your 0 plus 1, this is actually not there, I guess. We will start putting from 1 itself. So 2 by 2 factorial 1 minus 4 by 2 factorial, it will go on like that. This 0 term is not there. So I guess this is it. It was sigma r equals to 1 to 100. So now if you can work this out, this will exactly come to be this. So 3 by 2 factorial minus 103 by 102 factorial is what we had inside this bracket, this big sigma thing. And now this will be added with 103 by 102 factorial and multiplied by, I guess it was your 8 by 3. So this and this get cancelled. The 2 cancels 8 with 4 and 3 also get cancelled. So from here k is equals to 4 and m minus n is 0. So your final answer is 4. So this was it, guys, for this question. This was a good telescoping series question. If you have any doubts in this part, you can write down to me in the comment section, okay? Because this was some sort of tricky. You can always write down to me. Anyways, guys, I will now proceed towards the next question. So let's end today's video with this last question, which is a paragraph type question. This is a paragraph type question, guys. This one is the first question. This one is the second question. So you can try this out. I will reveal the answers later on. You can try this out if you want. I will wait for a few seconds and then start. Okay, guys, I guess now it's time to solve this. So because the image of the question has taken up my whole screen, so I will quickly change the screen. If you want, you can pause the video and write down the important credentials. Okay, I will read the question once also. So there is basically a curve y equals to f of x which passes through 0, 1, and the curve y equals to g of x, which is basically your integral minus infinity to x f of t dt, passes through the point 0, half. So from here one takeaway is that g dash x is equals to f of x. And it passes through the point 0, half, and then they have said that the tangents drawn to the curves at the point with equal abscissa will intersect on the x-axis. The area bound by the x-axis, the tangent and the normal to the curve at the point where it cuts the y-axis is, and then we have to find out a limit for which we need f of x. So this is going to be some sort of long, and this is also a difficult question. Okay, so I have written down the basics of the question. Now I will change the page. So first of all, let's go for writing down the tangent t of y equals to f of x. Say we can take this point as x comma f. Okay, like x comma f of x, I am writing it f for the time being. So the tangent equation will be, and I am denoting the coordinate axis for the time being with capital Y and capital X. So capital Y minus of f is equals to f dash x into capital X minus small x. So if you try to find out the point where it meets the x-axis, so you have to put capital Y as equal to 0. So I guess this comes out to be x minus f by f dash comma 0. And if you go on to the next part where we have to find out the tangent of y equals to g of x at, and if you observe, like in the question it said that the abscissa will be same, so x, and I'm writing this as g. So this thing will become capital Y minus g is equals to your g dash x into capital X minus small x. So once again we will need the point of x-axis, which is your, if we put capital Y equal to 0, I guess it's coming to be small x minus of g by f dash comma 0. So now we will use a very interesting principle here, and also one more thing guys, if you actually notice that g dash x was equal to our f of x. Okay, so actually I should have written this before. What I will do is g dash was equals to f, so I will replace this with f. Okay, and this is actually f. I did a mistake. X minus g by f comma 0. So these two intersect at the same point on the x-axis as given in the question. So we can equate these two. X minus f by f dash is equivalent to your x minus g by f, which means now we can write this as g of x. Now I am introducing the g of x and f of x, all these terms, because we will get a differential equation. Okay, so this comes out to be f square x whole divided by your f dash x, and now you know that if we, like, g dash x is equals to f of x, so what we will do is we will differentiate this equation. Okay, so differentiating this thing becomes g dash x is equals to your 2 times f of x minus of f squared x, and I guess now we will have a f double dash x whole divided by your f dash x squared. So that is the equation, and I guess what we can do now is we can substitute g dash x as f of x. So I have no space in this page, I will move on to the next page. So we can write this as your f of x, and now if we do a little bit of cross multiplication, what we will get is your, I am jumping I guess a single step, so we will actually get f dash x by fx and obviously we can integrate this to dx equals to, we'll have your f double dash x by f dash x, again a dx, and also integrate this. So pretty easy to integrate. We will have ln of f dash, I guess not f dash x here. We will have, okay, what I will do is I will write this as ln of f of x equals to ln of f dash x plus ln c. I just changed the sides, okay. So our f dash x, wait a minute guys, actually what I should do is, I am doing one thing, I am not writing ln c on this side, I am writing it on this side. Otherwise you will actually have c, that the final answer which will come, right, it is something of the sort of, I guess, a e power cx or something. It will become a e power x by c, which is bad to see. So I am improving the form. So basically we will have f dash x as equal to c into f of x. So once again we can integrate this, f dash x by f of x dx equals to integral c dx. So from here what we will have is our f of x. Again we will have a constant, so I am writing that constant as capital A. So ln of f of x equals to capital AC x, or rather we will have a e power cx. This will be, I guess, your final form. So we were given something that our f of x actually passes through 0 comma 1, or what we can write is f of 0 equals to 1, from where we actually get that a is equal to 1. So I will change the page and write this down. So now our f of x becomes e power cx, but job is not still done because we don't know c. So now for finding out c, we will actually try to use g of x, which was given to us. Okay, there was a lot of information about g of x as well. So we were given that g of x, this is actually equal to integral minus infinity to x and e power cx dx. So this thing is actually your e power cx by c, I guess, yeah, that's it. And now we have g of 0 given to be half. Why? Because 0 comma half is the point through which g of x was passing. So if you put this, you will actually get c to be equals to, I guess, 2. Am I correct? I will check once. Yeah, e power 0. Okay, I'm correct. Yeah, so g of x comes out to be your half e power 2x. And we all know that our g dash x is equals to f of x, which comes out to be equal to e power 2x. So this was a little twisty, but finally we have our f of x ready with us, which is e power 2x. It was all twisted and turned, but finally this is how we solve it. So in our first question, we had to find out the area bounded by x-axis, the tangent, and the normal to f of x, I guess at the point 0 comma 1. So let's write down their equations one by one. Tangent at 0 comma 1. The equation for this particular thing will be, I guess, y minus 1 equals to 2x. Why? Because slope is 2. If you want to find out the slope, f dash x is 2 e power 2x, and when you put x equal to 0, our m comes out to be 2. Okay. And also we can easily find out the equation for the normal. For the normal, the slope will be minus half, which I'm not writing. So it becomes x plus 2y. I guess minus, we will have x plus 2y minus 2. I guess no more constants, equal to 0. Yeah. So these are our two equations which we have to solve. So let's quickly graph this out and see what type of a curve is coming. So guys, if we try to graph this out, I will draw a rough coordinate axis. And I guess if we try to draw these two lines out, our x plus 2y minus 2 will pass something like this. This point is, I guess, 2 comma 0. This point is, I guess, 0 comma 1. And actually, if you observe our y minus 1 equals to 2x also, it is also passing through this particular point. Okay. And this point is half. So basically, the area which we were required to find, if I want to depict that with a, say, red color. So this is the area. This red colored shaded region will be your required area. So let's find that out quickly. This is not a big deal. So area, say if we name this something like ABD, area of triangle ABD will be nothing but half into base into height. So half, and your base is 2 plus half, because this is half, this part is 2, and this is multiplied by the height, which is 1. So this comes out to be, I guess, 5 by 4, which is your 1.25 units. So this will be the first part's answer. And in the second part, a pretty simple limit was given, which is limit x tends to 0, f of x square, so e power 4x minus 1 by x. So this is a very standard limit. E power 4x minus 1, we will divide and multiply with a 4. So this thing tends to 1. And so our final answer for the second part is 4. So the answers for this paragraph type question will be 1.25 and 4. So this was a good question, guys. I guess this was the best paragraph type question we have seen shortly. So that's it for today, guys. I guess this will be the final question for today. And I hope you liked the FitG Ai2Ts series. And I'm sorry for being a little late because my videos were coming late. I will try to upload regularly from now. So that's it. And if you have liked my content, please do like, share and subscribe, because it involves a lot of hard work to solve all this and bring it up. Okay. So that's it for today, guys. Any recommendations, please drop out to me in the comment section. I am always ready to read them. And thanks for watching.